Hello, my name is Max, and I am in fourth year software engineering.
Hi, I'm Cassidy, and I'm in fourth year software engineering.
Hi, I'm Matt in fourth year computer systems engineering.
Hi everyone, this is Bardia, fourth year software engineering.
Our project was to continue upon previous year's iterations to develop an autonomous mail delivery robot for the Carlton tunnels. The primary objectives of the project, defined back in September, were to develop a robot in such a way that it will reach from point A to point B to carry mail for a user without any interaction from the developers. The core functionality of the robot includes a state machine that controls the robot's turns, passing, collision handling, and intersection detection, as well as a dynamic navigation system. Throughout the project, a web application was also created to serve as a basic front end for the system and allow for users to interact with the robot.
The project is based on the iRobot Create platform, which provides a Roomba vacuum body that can be commanded using the ROS2 open source library. We have two robots, a Create 2 robot, which is continued from the previous year, and a new Create 3 robot designed this year. Both robots have a Raspberry Pi 4B microcontroller to run the state machine used to control the robot, as well as a LiDAR that is used to find walls for the robot to follow in the tunnels. The new Create 3 design has the Pi in the cargo bay connected to a dedicated USB-C port on the robot for communication and power. On top of the robot, the LiDAR is connected to the Pi using USB, and a letter organizer holds the mail as the robot navigates through the tunnels.
In addition to the LiDAR sensor and the Create robots, the project relies on Bluetooth beacons to locate itself in the Carlton tunnels. The robot's built-in bumper sensor is also used to detect any potential collisions. Together, the LiDAR sensor, the beacons, and the bumper sensor are the main sources of input for the system. The team combined all the possible input values and developed a state machine that can accommodate every combination of these inputs. This work is a step towards autonomous agent programming. In order to make sure the robot can safely navigate the Carlton tunnels, the team implemented dynamic navigation. We created a detailed routing table of all the possible intersections in the tunnels and how they are connected to each other. This ensured resiliency in the system and created a safe backup for when the robot veers off its original path.
To ensure that the state machine functions properly, a variety of unit and integration tests were implemented. The main components to test were the state machine, the action translator, the robot driver, and the captain. The state machine was unit tested according to the all transitions criterion to verify that the robot was always in an expected state and was performing its intended actions. To confirm that the data from the robot's sensors was being processed and sent correctly throughout the system, the components underwent integration testing through the use of a simulator. This simulator allowed the team to determine how the system would react given different environmental conditions.